Hello everyone, I am Jatan Upadhyay. I am a student of Masters in Construction Engineering and Management at S24 University. My student code is PCM23163. I work on high-rise residential project in the Studio 2, which is Construction Project Execution, Monitoring and Control. So beginning with the project brief, our project is located on the Amli Road near the ISKCON Circle and opposite of Karnavati Club and Novotel Hotel. The main project objective is to promote social togetherness by developing a residential community with all amenities, ensuring a wide-angle view of the surrounding at the prime location. The major amenities of the project is club with multifunctional hall, landscaped spaces, swimming pool, and gym space. The project contract type is square foot basis. The date of commencement of the project is February of 2023. The estimated date of completion is January of 2026. So coming to a water distribution layout of site layout planning. The project borewell is located nearer the site road, which is around 800 feet deep. Borewell provides all the water supply through distribution pipelines. There are two water tanks in which first tank is located near the borewell and another tank is situated nearer the quality control lab. The capacity of the water tank near the borewell is around 4000 liters and capacity of the tank nearer the QC lab is 2000 liters. As we can see in this layout, there are many water distribution pipelines on the site, which requires to carry out construction activities. The drain line, which is passing behind the site offices, connects all the washrooms located near at the entrance, QC lab, and client office. In the electricity distribution, main electrical panel of 400 ampere is located in the entrance of the site. Main panel provides electrical power to distribution panel, which is located near the engineer office. The capacity of distribution panel is 125 ampere. The distribution panel supplies electricity at all required locations, such as tower cranes and site offices. The first tower crane is located between the tower A and tower B, and another tower crane is situated nearer the tower B. So coming to a quality control lab on the site. The QC lab is situated nearer the safety offices. The total area of the QC lab is around 22 square meters. These are the different views like external views, internal views of the QC lab. There are lab equipment area, slum test apparatus, document storage, and staff working desk in the QC lab. The curing tank is located outside the QC lab, which is around 15 square meter. Talking about areas of improvement, the overall size of QC lab is very small, which is only 22 square meters. Another, there are absence of fire extinguisher in the QC lab. Also, the curing tank is located outside the quality office, beside the washroom, causing hindrance and unhygienic condition. After the considering all the areas of improvement, we prepared proposed plan of quality control lab, in which area of the lab is enlarged, which is around 56 square meter. Also, the curing tank is located in the QC lab. The area of curing tank is also enlarged. There are lab equipment area, material storage space, document storage, fire extinguisher, staff working desks, curing tank, dustbin, and lab technician chair in the quality control lab. These all are the 3D views of the proposed QC lab plan, in which we can see that we satisfied all the areas of improvements. So coming to a formwork calculation of port planning, in the site there are two towers, Tower A and Tower B. In the Tower A, there are two ports, port 1 and port 2. The size of the port 1 is around 415 square meter and the size of the port 2 is around 482 square meter. Coming to a Tower B, the size of the port 1 is 615 square meter and 677 is the size of the port 2. For the calculation of the formwork, we choose Tower B. The total slab area including beam water in the port 1 is 925. For the port 2, it is 841. And the total slab area is around 1766 square meter. We observe total 6 square meter area and consider thumb rule for the calculation of the formwork. From the help of the thumb rule, we derive quantity of various elements such as scaffolding verticals, base plates, forehead, lasers, runners, also data box, and etc. Coming to a productivity, so the productivity for column shuttering is around 0.65 square meter per man hour, which is higher than slab shuttering as aluminum formwork is used for columns and shear walls. This is the calculation of the direct cost for the formwork. To derive cost, we consider all the parameters such as my1 aluminum shuttering panel material, then plyboard, base plate, verticals, lasers, of scaffolding, then foreheads, runners, and data box. So, after the considering quantity and rate, the total cost for both ports, including repetition, is around 5 crores. Also, we derive quantity of repetition for the all segments. The cost excluding repetition is around 15 lakhs. Also, we derive cost of the formwork labor on the site. For the calculation of this, we consider various parameters like total days for formwork, labor working hours, required carpenters, cost of carpenters, total carpenter cost, and total helper cost. So after the considering all the parameters, we derive total cost per square meter for the formwork labor, which is 72 rupees. Also, we calculate formwork material cost on the site, in which after the summarization of total material cost, cost per square meter, labor cost, the total cost per square meter of labor around 10,000 per square meter. Coming to a future state mapping of value stream map. So basically, the value stream mapping is a lean production tool that allows visualizing and understanding the flow of material and information within a value chain. It is also defined as an improvement process that aims to maximum value by identifying and eliminating waste in the value chain. There are four main steps involved in the VSM process to be described. The first step is to define the activity or stage that needs to be studied and all the observation of the activity of the current scenario has to be noted. The second step is the creating current state map and the third step is design future state map and the last step is to create and implementation plan using the required lean tools. So to carry out value stream mapping, slab formwork using plywood is chosen. In this activity, there are some another sub-activities like assembly of labor, mobilization of tools, mobilization of U-jack, then mobilization of data box, of mobilization of ply, fixing U-jack to channels, fixing Tata box on U-jack, and the setting of ply. To reduce lead time of this activity, various tools of lean are applied, such as 5S, Kaizen, and Kanban. So after the applying all the lean tools on this activity, the total value added time which is 203. So basically value added activity is a value added step in a process are those which add something to a product or service, which change the product making it more closer to end product, and that step which is done right at first time. After that, the summation of total non-value adding activity and change over time is around 260. So basically non-value added activity is a steps in a process are those in which resources are used, delays occurs, and no value is added to the product or services. And the change over time is the amount of the time it takes to change over from the end of the previous step to the beginning of future step. So total lead time for this activity after apply all the lean tools in the future state mapping is 473 minutes. This is a take time calculation of value stream mapping. So basically take time is a rate of demand or ratio of available time to the demand. So for the calculation of take time, there are different parameters like total area of slab is 180 square meter, available time is 720 minutes, and working hours per day is 12 hours. Coming to observation taken on site. So total observed area of slide is 86 square meter and time taken for completion is around 608 minutes, which is current step time. Then in the future tag time, time taken for completion is 473 minutes and tag time after lean tools, which is around 5 minutes per square meters. So this is a graph which represent the current state and future state after the application of lean tools like 5S, Kaizen and Kanban. So the current cycle time is 608 minutes, which is reduced to 473 minutes in the future cycle. Also, we analyze that material mobilization trolleys can be used on the site for mobilization of various activities as observed during slab formwork, which shall help reduce the transport time. So finally coming to a key learnings for the all the exercise. So in the project brief, the basic details of the project were explained, which is location, project objectives, timelines, type of project, and scope of the work for various stakeholders. In the site layout planning, the site was observed and better proposal from our understanding of improved layout plan was prepared. This included the location of cranes, store, and washroom at the existing site layout. In the quality control lab, after the analysis of existing quality control lab layout, areas of improvement was identified. And considering all the improvements, proposed QC lab layout and 3D views were established. In the formwork calculation of port planning, carry out calculation for formwork of two ports at our site. Determine the coefficient which can be used for future planning. In the value stream mapping, for this, the slab bottom formwork activities was observed from 9 am to 7 pm. We observed the value and non-value adding times after which lean tools like Kaizen Kanban were used for lead time reduction.